When German soldiers spoke in the final years of World War II about the most terrifying weapon used by the Americans, few mentioned tanks or aircraft. It was not the M1 Garand rifle, nor the Sherman tank, nor even the dreaded B-17s overhead that filled them with dread. What many remembered most vividly, what truly froze their blood, was the thunderous, unrelenting precision of American artillery. Veterans like Obergefreiter Hans Müller of the 352nd Infantry Division would later recall that it was not just the volume of shells that frightened them. It was the speed, the coordination, and the accuracy that seemed to defy belief. The Americans, they said, could bring down a storm of fire within minutes of being spotted. To the soldiers of the Wehrmacht, who had once prided themselves on disciplined efficiency, this new kind of warfare felt like something mechanized beyond human scale. In the early stages of the war, artillery across the world still functioned much as it had in the Great War, relatively static, relying on line-of-sight observation and manual coordination. The Germans, with their reputation for technical brilliance, had entered the war with a powerful artillery arm, but by 1943 and 1944, their systems were beginning to show their age. Much of their equipment remained horse-drawn. Over 75% of German artillery units still relied on horses to move their guns across Europe and the Eastern Front. The Americans, by contrast, arrived with an industrially produced, fully motorized, and technologically integrated artillery corps that represented a revolution in battlefield science. The foundation of this revolution lay in the creation of the Fire Direction Center, the FDC. Before the FDC, calling for artillery fire was a complicated, often sluggish process. An observer at the front would report an enemy position, and that information would be relayed up the chain of command, converted into firing data by individual batteries, and then executed. This process could take many minutes, sometimes even half an hour, during which time the target might move, dig in, or vanish altogether. The Fire Direction Center changed all of that. It centralized and streamlined the entire process. Each FDC was staffed by highly trained soldiers equipped with slide rules, pre-computed firing tables, and radios that could communicate directly with multiple batteries. They could receive a call from a forward observer, instantly calculate coordinates, and within moments have multiple gun positions aiming at the same point on the map. This system allowed what became one of the most feared techniques of the war, time on target, or TOT. The principle behind time on target was both elegant and devastating. Using careful calculations of range and flight time, artillery crews could time their shots so that all shells from multiple batteries, fired from different locations and at different distances, would land simultaneously on a single target. The first warning a German platoon received was not the distant whistle of incoming shells, but the sudden, deafening explosion of dozens, sometimes hundreds of rounds striking at once. There was no time to run, no chance to find cover. As Lieutenant Friedrich Bauer of the 12th Volksgrenadier Division later recalled, it felt as if the earth itself had decided to explode. The effectiveness of time on target depended on speed and coordination, and American gunners became masters of both. The key was training and organization. Each artillery battalion was not an isolated unit, it was part of a network. When an infantry unit made contact with the enemy, forward observers, often positioned in small aircraft like the L-4 Grasshopper, would radio precise coordinates to the Fire Direction Center. Within 2 or 3 minutes, the FDC would compute firing data and relay it to all available gun batteries. The result was astonishing responsiveness. German commanders who had become accustomed to Soviet artillery that often took 15 to 30 minutes to prepare a barrage were stunned to find that American guns could open fire in less than 3 minutes.
It was not merely speed that impressed and terrified them, it was accuracy. American industry had produced not only thousands of guns, but also an enormous supply of precision tools, standardized ammunition, and detailed firing tables. These pre-computed tables accounted for factors like air temperature, powder lot, elevation, and barrel wear, allowing gunners to make adjustments instantly. Combined with the use of highly accurate maps and radio communications, the result was artillery that could strike targets with near-surgical precision across distances of several miles. Industrial power played a decisive role in this transformation. By 1945, the United States had produced over 8,500 howitzers and countless tons of ammunition. Its factories could turn out the shells, the powder, the spare parts, and the vehicles needed to keep artillery battalions moving and firing day and night. Unlike the Germans, who increasingly struggled with fuel shortages and supply disruptions, American artillery was mobile, well-fed, and fully integrated with its infantry and armor. This logistical strength meant that American divisions could move their guns quickly, reposition for new attacks, and maintain a steady rate of fire without pause. In contrast, German artillery often lagged far behind. Horses could not keep pace with tanks or motorized infantry, and the rough terrain of Russia and Western Europe took a brutal toll on men and animals alike. Even when German units managed to bring their guns into position, resupplying them with ammunition became an ordeal. Many German artillerymen later admitted that their inability to respond quickly to enemy movements and the sheer weight of American firepower left them feeling helpless. But perhaps the most revolutionary leap in American artillery technology came in late 1944 with the introduction of the variable time fuse, or proximity fuse. This small, brilliant invention changed everything. Inside the fuse was a tiny radio transmitter and receiver. As the shell approached its target, the signal would bounce off the ground or objects below. When the reflected signal reached a certain strength, indicating proximity to the target, the fuse triggered detonation automatically. This meant that shells no longer had to hit the ground to explode. They could detonate in the air above troops, spreading lethal fragments over a far wider area. The improvement in effectiveness was staggering. Studies showed that proximity fuses increased artillery lethality by as much as 300%. The proximity fuse was a closely guarded secret developed jointly by British and American scientists under the direction of the Office of Scientific Research and Development. It was first used in the Pacific theater against Japanese aircraft, but by late 1944, it began to appear in Europe. German soldiers facing American artillery in the Ardennes were among the first on the Western Front to experience its devastating effects. Shells that once dug craters in the earth now burst above them, shredding everything in the open. Foxholes and shallow trenches offered little protection. The Battle of the Bulge became the ultimate demonstration of American artillery supremacy. In December 1944, as Hitler launched his final great offensive through the Ardennes, the American forces found themselves under sudden, intense pressure. German panzer divisions surged through the snow-covered forests, and for a time the situation looked desperate. But the American artillerymen responded with unmatched precision and fury. In the first week of the battle, over 4,000 guns were brought to bear. Across the front, from Bastogne to Elsenborn Ridge, artillery fire thundered almost without pause. In total, during the course of the campaign, American guns fired more than 1 million shells.
At Elsenborn Ridge, the 2nd and 99th Infantry Divisions, supported by massive concentrations of artillery, held their ground against repeated attacks by German armor and infantry. Forward observers in L-4 Grasshopper aircraft circled high above the battlefield, calling in coordinates as soon as enemy columns appeared on the roads. Within minutes, salvos of 105 and 155 millimeter shells rained down, obliterating tanks, supply trucks, and infantry formations. German commanders, who had expected to break through with speed and surprise, found their assaults blunted before they could gain momentum. For the soldiers on the ground, the experience was unforgettable. American infantrymen came to regard their artillery as their guardian angels. "If we got in trouble," one veteran later said, "all we had to do was call for the guns, and in no time the world would explode around the Germans." On the other side, Wehrmacht survivors described their terror in equally vivid terms. "It was not human," one captured officer admitted. "We would be moving through the forest, and before a man could light his cigarette, the shells would come. Always where we were, always fast." This was not merely a triumph of machines, but of system and doctrine. The U.S. Army had invested heavily in training, standardization, and communication. Every division had its own artillery units, and those units were organized to support one another seamlessly. Fire direction centers linked batteries together across wide areas, allowing for massed fire on a single target. The communications infrastructure, from field telephones to radio networks, ensured that every observer, every forward company, could reach artillery support instantly. It was a level of integration unmatched by any other army in the war. American doctrine emphasized flexibility and initiative. Rather than waiting for higher command to authorize fire missions, junior officers and even non-commissioned forward observers were empowered to call for fire when needed. This decentralized approach allowed rapid responses and coordination across units. German forces, operating under stricter hierarchical control, could not match this agility. The Fire Direction Center also made use of advanced mathematics and data organization. Each artillery piece's performance characteristics were recorded and constantly updated. Barrel wear, propellant temperature, even humidity were factored into calculations. When a forward observer transmitted coordinates, the FDC could instantly adjust for all these variables, producing firing solutions tailored to each gun's condition. This was the unseen intelligence behind the thunderous barrages that Germans feared. By mid-1944, American artillery had become the most efficient killing machine on the Western Front. During the Normandy campaign, after the D-Day landings, artillery was used not only for defensive fire, but also for offensive coordination. Massive rolling barrages preceded infantry advances, breaking up German counterattacks before they could form. The psychological impact was immense. Many German prisoners captured after artillery barrages appeared dazed, deafened, and shell-shocked. They spoke of the rain of steel, a relentless pounding that seemed to come from every direction at once. In Italy, Tunisia, and later France, the pattern repeated itself. At the Battle of Kasserine Pass in 1943, American artillery performance was still developing, but by 1944, in the breakout from Normandy, the transformation was complete. Units like the 3rd Armored Division and the 30th Infantry Division routinely used coordinated artillery barrages to isolate enemy strongpoints and crush counterattacks. At Mortain, when German armored divisions launched a desperate counteroffensive to cut off the Allied advance, American artillery units responded with overwhelming force. More than 25,000 rounds were fired in a single night. The attack collapsed under the weight of shellfire before it could even reach the American lines.
Industrial capacity ensured that American gunners never lacked ammunition. Unlike the German or Soviet forces, who often had to ration their shells, American divisions could sustain continuous bombardment for days. The logistical network behind this effort was staggering. Fleets of trucks delivered ammunition to forward supply points. Rail lines and depots kept the flow steady. And every shell was manufactured to strict specifications to ensure consistency. This reliability made techniques like time on target possible on a massive scale. The role of the forward observer was equally vital. These men operated at great risk, often within sight of enemy positions. Some used ground-based observation posts, while others flew in light aircraft that seemed little more than canvas and sticks. The L-4 Grasshopper was one of the most famous of these. Pilots would fly low over the treetops, spotting targets and calling fire missions by radio. German troops learned quickly to fear the sight of these tiny planes circling above. The appearance of a grasshopper often meant that artillery shells were moments away. In many ways, American artillery represented the perfect fusion of science, industry, and tactics. It embodied the larger strengths of the United States in the war: technological innovation, logistical excellence, and the ability to coordinate complex systems on a vast scale. From the Fire Direction Center's computations to the assembly lines that produced shells by the millions, it was a national effort translated into battlefield power. By 1945, as the Allies pushed into Germany itself, the effectiveness of American artillery had reached its peak. In the crossing of the Rhine, entire German defensive zones were shattered by pre-planned barrages that used thousands of guns firing in precise synchronization. The sounds of these bombardments were said to roll across the countryside like thunder, shaking the earth for miles. German morale, already crumbling, often collapsed entirely under such fire. Units surrendered en masse rather than face another bombardment. For soldiers like Hans Müller and Friedrich Bauer, who had survived from the early days of the war, the contrast between their own artillery and that of the Americans was painful to acknowledge. In 1940, during the Blitzkrieg in France, German artillery had seemed unstoppable, fast, disciplined, effective. But by 1944 and 1945, it was they who were on the receiving end of a new kind of warfare. The Americans had turned artillery into something approaching an industrial process, mechanized, mathematical, and merciless. The lessons of that transformation endure to this day. The Fire Direction Center became the model for post-war artillery command systems. The techniques of time on target and rapid data computation formed the basis for modern digital fire control systems. The principles of flexibility, coordination, and centralized fire direction remain at the heart of modern military doctrine. Even the variable time fuse paved the way for modern proximity and programmable munitions. American artillery during World War II was more than just a weapon. It was a symbol of what total war had become. It was the application of science, organization, and mass production to the ancient art of hurling fire at the enemy. Its thunder echoed from the deserts of North Africa to the forests of Belgium, from the hedgerows of Normandy to the heart of Germany itself. And for those who faced it, there was little doubt about its power. When veterans of both sides looked back on the war, many remembered the same sound, the deep, rolling boom of American guns opening up in the distance, followed moments later by the earth-shaking crash of shells landing with uncanny precision. For the Germans, it was the sound of inevitability, the sound of an enemy whose industry, science, and coordination had created an unstoppable force. For the Americans, it was the sound of mastery, of a system that turned chaos into order and danger into dominance. The story of American artillery in World War II is, in many ways, the story of modern warfare itself, a blend of human ingenuity, relentless industrial effort, and the will to adapt faster than the enemy. From the muddy fields of Tunisia to the snowy ridges of the Ardennes, it was artillery that broke the German war machine's last great hopes. And it was artillery that taught the world that in modern war, the side that controls the data, the coordination, and the logistics of firepower will control the battlefield. Even today, military historians and tacticians study those systems, those doctrines, and those innovations. The Fire Direction Center, the time-on-target method, the proximity fuse, all remain milestones in the evolution of combat science. They remind us that technology alone is never enough. It is how it is organized, trained, and applied that determines victory. In the end, the Americans had turned artillery into an orchestra of destruction, where every shell landed like a perfectly timed note in a symphony of war. And for the men who faced it, that music was the sound of fear itself.